Hello and welcome to a new video on IGCSE mathematics. In this video, we shall be discussing solving simultaneous equations by substitution. In the first question, we're told solve these simultaneous equations and you must show all your working. We have 3x minus 2y equals 23 and negative 4x minus y equals negative 5. Now, in this type of question, we have two equations and two unknowns, and we're trying to find the value of the two unknowns, which are basically x and y. And there are two techniques of solving this type of question, either by elimination or by substitution. In this video, we shall be describing the technique of substitution, but bear in mind that this same problem could also have been solved by elimination, and there will be another video to describe how that works. So for substitution, our target is to isolate one of the variables in one of the equations. So which variable should we try to isolate? Normally, the easiest variable to isolate is the variable that has no number next to it, no coefficient, basically. So which variable is that here? In this case, the variable is y, because we have 3x and 2y and negative 2y and then negative 4x and then negative y. So the only variable that has no number next to it is the y, which I've underlined. So let's try to isolate that. How do we isolate that? Basically, we take it to the other side. So we get negative 4x equals negative 5 plus y. And then we transfer the negative 5 to the other side. So we get 5 minus 4x, or negative 4x plus 5, whichever you want, equals 2y. So this is the first step. We've isolated the y. Let me write that down. 1, isolate. And then the second step would be to substitute in the other equation. So don't use the same equation again, of course. You have to substitute the y in the other equation, which in this case would be the topmost equation. Let's try that out. So we have 3x minus 2y. And then instead of y, I'm just going to open a bracket. And then I'm going to write 5 minus 4x. And this equals 23. Now we have a single equation in x, and this is basically our target. All that remains to do is to simplify. So let's try to simplify this. 3x remains as is. Minus 2 is distributed onto the bracket. So remember, you multiply both terms by negative 2, not by 2 only. You have to multiply by negative 2. So you get 3x minus 10 plus 8x equals 23. And then further simplification here. You get 11x minus 10 equals 23. And 11x equals, you take the 10 to the other side, becomes 33. So x equals to 3. We divided by 11 on both sides. So just in case you don't understand the sequence here, in the first equation, I took the 10 to the other side with addition. So 23 plus 10 equals 33. So now I have 11x equals 33. And then I divided by 11 on both sides to obtain x equals 3. Having found the value of x, I need to plug in either one of the two equations in order to find the value of y. So the fourth step here would be to plug. And that's what we're going to do. We're just going to take one of the equations and we're going to put x as 3. So let's take the first equation, for example. So 3x, and instead of x, I'm going to write 3 minus 2y equals 23. Now, 9 minus 2y equals 23. And then we take the 9 to the other side. So negative 2y equals 23 minus 9, which is basically 14. If you divide by negative 2, you get y equals negative 7. So you have y equals negative 7. You have x equals 3. And that is the final answer. It would be a good idea sometimes, actually all of the time, it would be a good idea to check. How do we check? We check by plugging both values into the second equation and figuring out whether they work or not. So I'm going to take this equation here, and I'm going to plug in the x and the y in order to verify that they do work correctly. So negative 4, and then instead of x, I have 3, and then minus, and instead of y, I have negative 7, and then equals negative 5. So let's try that out. Negative 4 multiplied by 3 gives me negative 12, minus negative 7, so that's plus 7. And this, in fact, does give me negative 5, so this is correct. I've now checked that my two values are both correct. Now, if you want to check our answers, remember we got x equals 3, y equals negative 7, and these are the correct answers. In this question, we have two simultaneous equations as well. But in this case, we cannot use elimination. We can only use substitution for the following reason. Now, these equations I'm currently writing on the screen are all examples of linear equations. How are they linear? Why are they linear? Because you have x and y. The x and the y are not multiplied by each other, and they do not have any powers. So they have power 1, basically. They're not power 2 or power 3 or anything of the sort. So all of these would work for elimination, because for elimination, you have to have two linear equations. However, there are other types of equations which are non-linear, like, for example, y squared equals x minus 5, xy equals 7, 2x squared minus y equals 3. Anything that has x power 2 or y power 2 or x multiplied by y is a non-linear equation. So in this case, if we have a non-linear equation, we must use substitution. We cannot use elimination. And fortunately for us, this is the video that explains substitution. So we can solve this problem using the same technique as the previous problem. So what was our technique? Let me list down the steps quickly. Isolate, substitute, simplify, plug, and check. These are the 5 steps of solving a system of equations. In our case here, step 1 is already carried out for us because the y here is already isolated. We have y equals something. So step 1 is already complete. Step 2 would be to substitute. So we're going to move to the second equation, and we're going to substitute the value of y that we have. So x squared plus 2, and then instead of y, we have 4 minus x, but it's y power 2, so we just raise the bracket to the power of 2, and this is equal to 67. Now, I need to simplify. I've finished substituting, and we need to simplify this equation. You might want to write it on the side just to help out yourself. How do you find 4 minus x all squared? either you use the shortcut of a squared plus b squared plus 2ab, or you just write it out as two brackets multiplied by each other. So you just have 4 minus x times 4 minus x. And first times first gives you 16. First times second gives you minus 4x. Second times first, again, minus 4x. And second times second gives you plus x squared. And if you simplify this further, you get 16 minus 8x plus x power 2. And we can write it instead of this bracket here. So we have x squared plus 2 multiplied by 16 minus 8x plus x power 2. And this is equal to 67. Next, we distribute the 2 as part of simplifying over the different values of x. So we have x squared plus 32 minus 16x plus 2x power 2. And this is equal 67. Now we have values for x power 2, values for x, and numbers without any x raised to any power. So how do we solve this? By basically forming a quadratic equation. We're going to take all the values to one side, we're going to simplify, and we're going to end up with a quadratic equation. So let's try this again. X power 2 plus 2x power 2. This gives us 3x power 2. And then we have minus 16x. Notice how I'm moving from high powers to lower powers. And then we have plus 32. And we take the 67 to the other side, so it becomes minus 67 equals to 0. Now, if I want to simplify this further, I would write it as 3x power 2 minus 16x, and then 32 minus 67. That gives you minus 35 equals 0. Now, since you have access to your calculator, you can just do mode 5-3 and plug the 3 values in and find the answers. So let me go ahead and do that. I'm going to use the calculator. I'm going to write 3 for A, negative 16 for B, and negative 35 for C. And the calculator found 2 values for X, negative 5 over 3 and 7. So let's write these down. X equals negative 5 over 3 and X equals to 7. And we're done with simplifying. Now, for steps 4 and 5, we're going to have to repeat them for each value of X. Since we obtained 2 values of X, we have to plug them both in, find the corresponding Y's, and then check to make sure that they work. So for the first value, I'm going to use this top equation for plugging, and I'm going to use the second equation for checking. So for plugging, we have y equals 4 minus, and then I put the first value of x, which is negative 5 over 3. And then this gives me 17 over 3. So when x is negative 5 over 3, y is 17 over 3. And when x equals to 7, again, I have to plug. Four minus 7 gives me negative 3. Now, in the exam, if you don't have time, you don't have to do the check. It's just a good idea to confirm your answer. But if it's going to take too much time, because here in the second equation, you have everything raised to the power of 2, and checking requires more substantial algebra, so it's not always necessary to do the check. It's just a good idea if you want to make sure your answer is correct. In our case, let's just go ahead and check the answers. So let me just erase some of the steps so that you can see the answers more clearly. Remember, our two answers are -5/3 and 17/3. Let me write these down again. Our answers were x equals -5/3, y equals 17/3, and x equals 7, y equals -3. And if we check the final answers here, we're going to find that they are exactly the same. Of course, this is a mixed number, but it's equivalent to 17/3. So both of them are correct. So this is how you solve a pair of simultaneous equations where one of them is non-linear. Moving on, back to systems of linear equations. So of course, this is linear because there is no y power 2 or x power 2 or xy term, right? So these can be solved either by elimination or by substitution. We're doing substitution in this video. So again, let's review our steps quickly. Isolate, substitute, simplify, plug, and possibly, optionally, check. If it's easy to check, then you check. So we begin by isolating the variable. So which variable should we isolate here? It's always smart to isolate the variable that has no number next to it, because this is the easiest one to isolate. So let's begin by isolating the x here. We're just going to take the 2y to the other side, so it becomes 9 minus 2y. And then we're going to plug that into the x of the second equation. We're going to substitute that, into the x of the other equation. So we have 2, and then instead of x, we have 9 minus 2y plus 3y equals 13. And then we distribute. So we have 18 minus 4y plus 3y equals 13. Bear in mind, we have finished isolating, substituting, and we're currently in simplifying. Now, minus 4y plus 3y, that gives you -1y. So 18 minus y equals 13. We take the 18 to the other side. So -y equals 13 minus 18. -y equals -5. If you multiply both sides by -1, you get y equals 5. And we're done simplifying. Next, we plug the value of y into either one of the two equations. It doesn't really matter. So we have 2x plus 3y. Instead of y, I'm going to write 5 equals 13. So 2x plus 15 equals 13. You take the 15 to the other side, you have 2x equals -2. 13 minus 15, which is -2. And then divide by 2, you get x equals -1. So the final answer is actually x equals -1, y equals 5. If you want to do the extra step, here it's not too hard, so we can try to check. We're done plugging, now we check. We're going to use the second equation, which is x plus 2y equals 9. And we're going to plug our two values just to make sure that they provide the correct answer. So -1 plus 2 times 5, which is basically -1 plus 10 equals 9, and this is correct. So we've confirmed that our two values are indeed correct. X equals -1 and Y equals 5 are the correct answer. Let's try this again. I will quickly write down the steps. Isolate, substitute, simplify, plug, and check. So ISSPC. Isolate, substitute, simplify, plug, check. Now, the easiest variable to isolate here is either this x or this y. They're both easy because they both have no numbers next to them. It's up to you which one you want to use. I'm just going to use the x. So we're going to rewrite the equation as x equals 2y plus 2. I isolated the x in the second equation. So we're done with isolating. Next, we substitute. So half x, let me write this down, half, and then instead of x, I'm going to write 2y plus 2 plus y equals 8. And you distribute, so we're done with substituting now. We go on to simplifying, and we distribute the half over the bracket. Half times 2 is basically 1. Half multiplied by 2 over 1 gives you 1. So half times 2y is y, half times 2 is 1. And then you add y, and this is equal to 2. Excuse me, this is equal to 8. So you have 2y plus 1 equals to 8. 2y equals to 7. Y equals 3.5 or 7 over 2. We're done simplifying. Next, we plug and check. So first of all, y equals 3.5, and we want to find the x. So x minus 2y equals 2. X minus 2 times 3.5 equals 2. X minus 7 equals 2. X equals 7 plus 2. And x equals 9. Having obtained my value of x, I proceed to check. I'm going to use the second equation, or actually here the first equation. So half x plus y equals 8. Half times 9 plus 3.5, which is basically 4.5 plus 3.5. And this gives us 8, and this is correct. So now I'm confident that my two values, 3.5, and 9, are both correct. Let's check our answers. X equals 9 and y equals 3.5. Again, here we have two equations, y equals x over 2 and 2x minus y equals 1. Remember, you don't have to write down the explicit steps, but now I'm going to write ISSPC, and I remember isolate, substitute, simplify, plug, and check. So isolating is already done because in the question itself, y here is isolated, so I don't need to isolate anything. Now I move on to substituting. So 2x minus y, which is basically x over 2, equals 1. I just substituted here. And 2x minus x over 2, you need to understand that x over 2 is the same as half x, which is the same as 0.5x. These all mean the same thing, actually. If you don't know how to work with this, you can just try to have a common denominator. So you want this to be over 2, So you need to multiply here by 2. So you get 4x over 2 minus x over 2 equals 1. So 3x over 2 equals 1. Excuse me, I apologize. So 3x equals 2. I took the 2 to the other side. And x equals to 2 over 3. And that's my answer for x. So we've done substituting and simplifying. Now we need to plug. So I'm just going to use the equation y equals x over 2. And this is equal to 2 over 3 divided by 2. 2 over 3 over 2, which is the same as 2 over 3 divided by 2. And this is also the same as 2 over 3 multiplied by 1 over 2. And you can cross out 2 and 2, and you just get 1 over 3. So we have the values of x and y. X equals to 2 over 3. Y equals to 1 over 3. And we're done with plugging. Next, we check. How do we check? We use the second equation. 2x minus y equals 1. So 2 times 2 over 3 minus 1 over 3. So 4 over 3 minus 1 over 3, which is basically 3 over 3, which is 1. So this is correct. And our values are 2 over 3 and 1 over 3. Let's check the marking scheme. X equals 2 over 3. Y equals 1 over 3. This is correct. In this problem, we have, again, two simultaneous equations, and we remember our methodology. ISSPC, isolate, substitute, simplify, plug, and check. Here we have to do some work in the isolation because none of the variables have no numbers next to them. All the variables have numbers. So it doesn't matter which variable we choose, really. And whenever you have this case where all the variables have numbers next to them, it's usually a better idea to use elimination than substitution. But I'm going to show you that substitution works as well by solving this question using substitution. So if I have 2x plus 3y equals negative 12, I can try to isolate the x here. So you have 2x equals negative 12 minus 3y. Now you need the x to have no number next to it. You have to divide everything by 2. And you have x equals negative 6 minus 3 over 2y. And we're done isolating. Next, we move on to substituting in the second equation. So you have 5x, and instead of x, I'm going to open a bracket and write negative 6 minus 3 over 2y plus 2y equals 14. Now you need to multiply, to simplify, I mean. We're done with substituting, now we're in simplifying. So I just distribute the 5 over the bracket. I have negative 30 minus 15 over 2y plus 2y equals 14. To simplify further, you can always write this as a decimal if this helps. You can say negative 30 minus 7.5y plus 2y. You just do 15 over 2 on the calculator, and that gives you 7.5. Now we have 2y equals 14. So negative 30. And then negative 7.5 plus 2 gives you negative 5.5. Y equals 14. And then you take the 30 to the other side. Excuse me. You take the 30 to the other side with addition. So you have negative 5.5y equals 14 plus 30, which is basically 44. So y equals 44 over negative 5.5. And you can use your calculator to figure this out. Excuse me. You just do 44 divided negative 5.5 on the calculator, and that gives you negative 8. So I've obtained the value of y. Next, I need to plug. So y equals negative 8. Plug it in either one of the two equations. We have 2x plus 3y, so plus 3 times negative 8 equals negative 12. So you have 2x plus negative 24 equals negative 12. So you have 2x equals negative 12 plus 24. 2x equals positive 12. And x equals to 6. If you want to optionally check as well, you can always try to do that in the second equation. So we have 5x plus 2y equals 14. I'm going to use the second equation here to check. So we have 5x is 6 plus 2 and y is negative 8 equals 14. So 30 minus 16 equals 14. This is a correct statement. 30 minus 16 is equal to positive 14. So we're done as well with plugging and checking. And we've obtained our final answer of x equals 6, y equals negative 8. Let's check the marking scheme. You can probably see the answer is correct. X equals 6, y equals negative 8. And this brings us to the end of our video. Thank you for watching. I hope this has been beneficial to you.